All right, please let me know if the audio is now better. Thank you. Yeah, it's kind of annoying. I really like for any type that is static. I guess this doesn't actually hold even if it is static because bound can totally be static, but I still want to change the type for the query ID. Anyway, it's irrelevant. Because for any AST that contains any non-static node, I still have to implement this for the entire AST. So that's fine. Okay. I'm going to put this here too before I forget. Target. Oh, I can't even just actually write the type of target, can I? That's hella annoying. Let's do this. All right. So we're going to need to do this for where clause. I'm going to go actually copy. I'm going to put this in a buffer so I can stop writing this over and over again. I guess this will be 0 indentation, won't it? And then for where clause, this is wrong. This needs to be this. I'm gonna have to go fix it for table. I'm going to forget to do that probably, but the compiler will tell me eventually. Okay, we need to do it for EQ, or actually all predicates, or all binary predicates, more specifically. I mean, we sort of do already have static methods in Rust. That's just not taking self as an argument in a inherent method. Or do you mean like being able to call them as methods that take self as an argument? The one thing I do like about this structure we landed on is I don't have to import standard any type ID everywhere. Okay, we need it for order, or more specifically, any simple clause, because that's where that's going to be defined. We'll need it for both the true case and the false case. I just realized I intend to remove this DB parameter. I was just thinking, should I do that now? But we're so close to being at the next step that we'll wait. Eh. All right, and then the last one we need is descending. Is that just a postfix? It's not really a predicate. I don't know why oh, that's why I call it postfix expression. Um, we're having to use it here because since I'm fully qualifying, I know it's not already being used, so otherwise it won't be able to resolve this method. Is that everything? Distinct. Nope, I added it to clause. No, distinct doesn't use that macro. Because distinct is special in that it's always a literal. Okay. Helps remember to import things. This is why the compile time is factorial time. Because one error, one wrong line generates all of those errors. Type ID is not a member of query ID. That is correct. Oh man, I'm more tired than I thought I would be today. It's been a long day. Looking good. Okay, so that's conflicting with the specialized implementation, I think. Oh, I guess I can't rely on, because now this implementation is coming from out of crate, so it will let me rely on less. So I need to prove that it is in fact specialized. So does anyone have any questions on the code so far? Backend is not in scope. There's nothing is in scope there. Oh, actually, that was the wrong line. One thing that I didn't show on stream yesterday, but if you, I'm going to remember to close Chrome this time afterwards. If you go take a look at the pull request, that came out of yesterday's stream. You know, I did a bunch of work in progress commits, and then there was still some code at the end that I was like, this is kind of messy. I need to move all this around, right? And so I turned warnings back on and cleaned things up. In particular, all of those things that were nagging at me, like pull this into an off function, all happened, which actually none of that would be in this pull request because this pull request was not from yesterday's stream. This is the one that was from yesterday's stream. And of course, there was a ton of code because we did, in fact, go and add this method to every single node in our AST, which I'm looking at maybe ways to make it easier to add these. But what I wanted to get, the main thing I wanted to point out is that I do a lot of commit message writing because I think it's really important. Like these are what I have instead of code comments because code comments get out of date really fast. And when I want to know what the hell I was thinking, I get blame. So it won't just be what I did. In fact, it will have very little of what I did. It'll be why I did it, why it's a certain way. In the case of this one, it does have a little bit more of what I did because it's 424 lines, so I need to separate the noise out a bit. I try and keep them a bit smaller usually. But yeah, and then that just ends up being the commit message or the pull request message. Anyway, I don't know if I have a point there other than write long commit messages, but write long commit messages. Still conflicting implementations. Oh, I know what it is. CodeGen's not building against Diesel with specialization turned on. Again, this won't actually use specialization in the final implementation. Why do I get the... Well, no, of course it's recompiling. Do I also need to do this? Yes, that was what I needed. Okay, cool. And I'm going to need to do the same thing in here. It's complaining because it can't infer the backend because there would be no reason for it to need to infer the backend because we don't use the backend because the backend was just a hack. But I will just do that. And this name is now really misleading, but I don't care because it's going to get deleted in a minute. Just doing that to make sure I did implement this for only the nodes that I need to. Because again, I'm going to implement this for the entire AST, but for now, I'm just wanting to implement it for just enough to make this. Oh, we forgot to do it for bound. And so we don't care about U at all here. Because U is the type of the thing being serialized. So in this case, it would be a stir. So I'm going to put in empty tuple there because I know we definitely know empty tuple is static. Even though that should always be true, that's technically more correct. And now we wait for it to compile. What? How is that now failing? How would adding an implementation for bound cause no distinct clause? That's a bug. That's gotta be a bug. I'm tweeting at Aaron and Nico. Letting them know we found a bug on stream. Quick, before I actually send this tweet, this is a bug, right? This is very obviously a bug. This is very obviously a bug. All right, well, we'll see if either of them pop in here. So I guess this will make it, probably. The bug's actually probably that was compiling in the first place, because now I think about it, that's not... No, that is more specific. Yeah, that is strictly... This is a concrete type. That is strictly more specific than T, where T implements... Anyway, that should make it more strictly overlap. My dog is awake. His name is Django. My cat's name is Sinatra, by the way, who I had on camera earlier. My pets are all named after web frameworks. Looking good. Alright, what the heck did I miss? Okay, we did tuples. I'll bet it's nullable is the thing that I missed. Where the heck do I do it? Impulse option? Yep, this is what I missed. And that should always be true, but technically more correct to write it that way. I don't even know if Query Builder is like the semantically right module to put this friggin' trait is in. Yeah. Like, we're just making completely unrelated things fail to compile every time we add a new impl. That is such a bug. Wow. That's actually really bad. Again, the bug is, like, this actually shouldn't... I don't know if it should be compiling or not, actually. I think the bug is that it should not be compiling before I make these changes. Even though there's not actually overlap. Or at least we're never invoking a case where there's overlap. I'm not sure whether the bug is I'm having to do this change or that I didn't have to do this change in the first place, but... Okay, well, that compiles. I'm going to look at that type signature and just make sure I didn't forget any other AST nodes. We've done it for so much of our AST. I may as well just do it for the rest of them, but... Okay, we've got it for tuples. We've got it for SQL types. We've got it for nullable. We've got it for columns. I forgot inner join. Or left outer join source is the one. Left outer join. that can fit on a line, I think. Okay. Did tables. We did no distinct clause. We did where clause. Okay. Did tables. We did no distinct clause. We did where clause. We did EQ. We did columns. We did bound. We did that. We did all of these. This should now pass. / be faster. When it finishes compiling. Which will take a minute. But we'll get there. I'm really excited to see this number. It's not actually going to be like super impressive. It'll probably be I don't know. I actually have no idea how much of that 21 microseconds is round trip time versus query builder time. We are still doing a horribly inefficient hack in our implementation of 2SQL for SQLite, so that doesn't help either. What the hell did we forget to give a static query ID? I wonder if it's one of those cases where, like, it's just picking a less specialized thing. Did I mention I'm a print line debugger? Because I'm a print line debugger. Oh, good. Lib syntax is a breaking change coming. I'm now frantically, periodically checking my stream preview. I'm like, I didn't forget to close documentation this time, right? Almost. I need to If I'm going to keep doing this, I got to get some setup where I have a separate machine responsible for the video encoding. That didn't print to standard out at all. Of course. Of course it wouldn't, because... No, why? Of course it would. Is it not using the specialized impl for select statement? That would mean one of these doesn't hold, but they would have to. Because for this to hold, these would all have to hold. I guess with that exception. All right, here's what I'm going to do. I'm going to try each of these segments. Until one of those fails to compile. I might have just, yes, I might need to just actually remove specialization and implement it for reals. Okay, so that compiled. So the SQL type is definitely implementing query ID. Right, because I'm not crazy. The fact that it's not calling this... Do benchmarks capture standard out? Before we go down this rabbit hole. No, it's not. Or yes, no, it does not capture standard out. So if it were printing, it would, or if it were calling this impl, it would be printing that out. So, okay. Next, let's get the second type, which is this. Let's just make sure. I don't know. That still compiles. Aha. Well, that holds, so then it must be in the tuple case. This will test my hunch of, like, it's doing the wrong thing because we're not actually specializing. And this is why the feature is still unstable. / partially unimplemented. Be right back, guys. My wife just got home. I'm going to let the dog out. Did it work? Okay, so now the select clause holds. Let's see if it runs. I was kind of hoping to have this like, and look, when we finish implementing it'll be really fast, way sooner than this. Okay, so we got the select clause. Let's check that the from clause still implements it. I feel like I'm sort of validating a lot of the concerns people had about specialization, where I'm now like, why isn't it using the specialized thing? Although I guess this is no different than any time a trait impl doesn't hold. Okay. So if that doesn't hold, that means one of the tables must not hold. There we go. Yeah, I really hope that maybe Aaron or Nico pop into the stream so that we can show them there's actually this bug here. Although this is wrong. No, it's not wrong. This is right, because it never implements query fragment, because it's not a query fragment. It gets converted into a from clause. But the other cases, though, were definitely demonstrations of a bug. Okay, what the hell do I have to do to make these not overlap? You know what I could do? Bam. I mean, yes, I did just make it overlap more, but I made this the least specific impl possible. So literally any impl that isn't exactly that implementation would have to be more specific. So there cannot be overlap. Of course, now it can't actually infer SQLite there because we don't have that constraint anymore, but that's fine. Okay, so now it would have to use the specialized info for select statement. And hopefully if we were still missing any cases where it wasn't using the more specialized impl, that they will be cases that are different enough that we don't have cache overlaps. Again, all of this will not be a problem when I just remove the blanket impl entirely. Because that was the goal was to not have to implement it for everything, and it would be faster that way. And I'm now starting to question whether that has actually saved any time versus just having the compiler tell me, no, you forgot to do it for this trait or for this type, and I guess that's the compiler telling me that there are multiple impls. How's that a compiler error, but then it ran? So print it up to 5. Since the where clause isn't implemented. Why is it running this at compile time? What the heck? Why is... Why is it running that function at compile time? I mean, I get, like, the whole point of this is that it's calculated as a compile time literal, but not by literally running the function, by the optimizer catching it. If there are print lines and asserts, that shouldn't be done at compile time. I am so confused. Luckily, this is all on video. I will never give up. Until it's time for dinner, and then I will go have dinner. Okay, so this must not be holding. Do I export where clause publicly ever anywhere? Do I have to really? I do not. So we will make that public so that I can. And I will save the file. Oh, yeah. Yeah. I really don't know what to say about that. That is very surprising that it was yeah. Okay, so that compiled. So the where clause is fine. So that means that the... What was the last piece? I don't know if we ever checked the distinct clause explicitly. We've definitely checked... Well, we checked that the tables were. We never checked the from clause. All right. Oh my gosh. We're gonna delete this default impl. Crap, and I can't make that a super trait. I just have to restructure a bunch of stuff to make this, like, proper, and I don't want to do that right now. Alright, one last try. This maybe now doesn't conflict if I do that. Because that is strictly more specific. It was already strictly more specific, but now it's more strictly more specific. We're now definitely at the point where if I had just not tried to cheat and use unstable, partially unimplemented features to do less work for my proof of concept, um, we would be done. But now it's like sunk cost fallacy all the way. So I hope this is entertaining at least. As I break the Rust compiler. Oh? That doesn't look specialized, though. That looks like my assert would still fail. Okay, well, I can delete that. The off chance it wasn't using that. Okay, so the where clause is specialized. And that's its type ID, apparently. Sorry that there is so much compiling in this stream. I usually like to work in slightly larger steps than this, but again, I'm still in the I don't know if this is possible stage. We saw it was possible for the select star from users case, which is good. And it was it 300, 400% faster? 1 core at a time. That's 400%. Okay. So we've checked the where clause. Let's check the order clause. Then I will double check distinct clause. Wait, of course this is going to hold for all of them because it's... Okay, you know what? It's going to be... Hold on. Yeah, of course that's gonna compile because we implemented it for all T. So that's not helpful. So what I'm gonna do is true. And then, as long as this does not cause overlapping cache hits, which it shouldn't, I hope. And then I can delete my specialized impl and go back to the compiler actually helping me by telling me the types I haven't implemented it for and not running my code at compile time that is not meant to be run at compile time. Well, okay. I mean, right, that's trivial case is still way faster. But it looks like our query builder overhead was actually closer to I mean, we'll see what the exact number is, but I think the medium complex query was something like 23 microseconds before, so. I mean, it's fine. Like, I can decrease the hashing work. That'll help. As was mentioned at the beginning of the stream, if I use since I've got U64, I can use a perfect hashing function there instead of a regular hash map. But the important thing also is I really wanted this benchmark to be under a microsecond. And in general, our query builder will now be under a microsecond because our query builder is now free. And while it might not be a huge bottleneck, it is very important to prove out, especially in sort of the use cases that I'm targeting Diesel for. Yeah, so I mean that's fine. That's 20% faster. And it's not the trivial query case where it's 300% faster, but or 200%, 300%. But it's fine. But, you know, when I announced the framework, like it's interesting. The way we grow our user base is sort of targeting two markets. The first are people who just aren't using Rust, and we sort of grow Rust as a language. And the other one is there are people who ORMs have left a really poor taste in their mouth. And Diesel really is very different, and it's designed to fix a lot of like. This is where I pour the lessons that I've learned from maintaining Active Record for the last couple of years. And seeing how people use and misuse ORMs and where things can go wrong and where performance issues live and where maintainability issues live, most importantly. But a lot of these people are also like, well, ORMs always have performance cost. And people are, you know, I say query builder first because it is a query builder first and an ORM second. And so I think to target that market, our query builder not imposing any cost is huge. So even if it's not actually a significant bottleneck in most applications, it is a performance win, and I always like performance wins. It is the ability to say that using Diesel's query builder will generate a prepared statement faster than a SQL string literal would. And it's marketing. I mean, it sucks to say it, but that is a thing that we have to care about to gain adoption. Um, all right, so let's go ahead and do some of the restructuring that we're going to need to make this like for reals. So what do I need to do? I need to commit. Okay, so we can get rid of you and you. This is correct again. And then let's go ahead and I'm not going to implement it because I'm getting kind of hungry. So I'm not going to implement it for the entire AST today, but I do want to get to the point where the overall structure is in the right place where the compiler errors that I'm getting are, and you need to implement it for these types. I'm going to leave this DB constraint on just because that will get us to that point slightly faster. I'm touching the wrong thing. And then, so let's just go through, right? And so in SQLite connection, in prepare query, this needs to be plus query ID SQLite, which will eventually just be plus query ID. This becomes plus query ID SQLite. I'll leave that explicit cast there, and I'll remove it later. And then everything that's calling prepare query is going to have to do this. So plus query ID backend. The reason that is self backend here is because this would have been copy pasted from the signature in the connection trait. Which is where this is going to need to go now. So we'll need to put that same constraint on query 1 here. Query all and execute returning count. These methods are originally actually were the public API. They are no longer methods that their names are kind of funky because they're no longer names that you would call publicly. Which is why they're all doc hidden. But these do map one-to-one with a method that you call elsewhere. So query all is what gets called, like literally the implementation of load is just calling query all. But the other nice thing is that when type inference couldn't work with this load DSL, the amount of type parameters you have to specify is much nicer. I mean, it's only one less, but it would, this would have been under otherwise underscore and then the type that we're deserializing to. I'm not gonna bother with PG right now because we're just not compiling with PG flags turned on. Whoops, did not mean to commit that. Let's import query ID. Now, what I prefer to do instead of changing all these signatures is put query ID as a super trait of query fragment. But I can't do that because query fragment needs to be boxable. And so if I made this a super trait, well, it would actually just remove the ability to box it entirely because I have methods that are not object safe. But number two, even if I did have methods that were all of the methods were object safe, to box up that trait, I would have to specify the type of query ID, which sort of defeats the entire purpose of having the trait object because the type would change for every unique type. So all that to say, I just have to add this constraint in a few places, and that's not a big deal. So I need to, in query DSL, or load DSL rather, mirror the same change. So when I say query fragment con backend, that also needs to be plus query ID con backend. That issue with boxing has actually led to a few things that are really funky that I wish I didn't have to do. For example, when I was implementing it, if you go look at the code related to query fragment for the box select statement, which let me just pull up if I'm going to talk about it, instead of just talking about code without showing it. So notice in all of these methods, right, the code looks pretty uniform, except for where clause. Right? And then down here, code looks pretty uniform, except for where clause. And then over here, the code is like almost line for line identical, except for where clause. And the reason for that is where is treated specially in our query builder DSL. It is the only one where multiple calls is append instead of replace. So by that, I mean if you call filter multiple times, it will be, so if I do like dot filter, so if I do dot filter foo.filter bar. This is equivalent to if I did dot filter foo and bar. Whereas for something like select, or if I do dot select foo dot select bar, here it's replace. So that would be equivalent to just doing dot select bar because the foo gets overridden entirely. And what that meant was basically where clause has to go in a box, so that I know if there's an existing thing or not. Now, I avoid having to do the option stuff. Okay, popping another layer down the stack here. This is actually really cool. We have this test called perf details. And this constructs some arbitrarily complex queries. Nothing crazy, but this could scale up infinitely. But something like users inner join post.filter name eq title. Right, so we've got some, we've got a where clause, we've got some equality. The important thing is the where clause. And we're asserting that the size is 0. And what that means is that everything that we do in our query builder, this is basically a test saying we wrote our query builder in such a way that everything can be inlined. Because if the size of it is 0, I can't branch on anything meaningful. Unless I have the constraint of any on there, which I'm now sort of adding for one place, but not for not for query builder. And so what that means is that code ends up being free of branching after monomorphization, and that's why diesel can become so fast, or at least why the query builder can become so fast, even without this prepared statement caching nonsense that we're doing right now. And so the way we avoid having an option there is we, if you look at DSL impl for for filter DSL on select statement. Right, we just call where clause and other thing. We don't have two cases. We actually have n cases. We just happen to only have two types that implement this trait. And that trait is called where and. So we have two structs here. We have a struct called no where clause, and we have a struct called where clause. Right, and so then I have to go implement. So the actual conditional of whether or not we add that string where is just based on which of these traits gets called. I mean, and this is literally, if you come from an OO language, right? This is polymorphism, haha. And I mean, it's the null object pattern, right? And but in a language like Rust, it's actually really cool that we can do stuff like this. And this is, of course, much more verbose than if we just use an option. And then what ended up happening was I realized for the boxed case, I had to use an option anyway, so I sort of have it both ways now. But the reason that we have to use the option in the boxed case is because I would end up wanting to box query fragment plus where and, right? And if I'm going to box where and, I have to specify this output type. Predicate here would just be box. Well, actually, I don't even have to go to specifying the output, right? I can just talk about it in boxing the in what the type of predicate is. So self is query fragment plus where and then where and needs that type specified, right? And the type that goes in there is box query fragment plus where and. which takes a predicate, right? And so that becomes an infinitely recursive type. And so we wouldn't be able to do that. I had a point that I was going to make from all that, and I don't remember what it was, so I'm going to go back now to load DSL. Actually, I think I've finished fixing all of those errors anyway. Nope. Load DSL, line 12. Right. Come on, guys. I'm surprised I just went through all of that nonsense and nobody has a question or just telling me that my code is stupid. It's okay, by the way. My day job is just making Rails, so I get people telling me my code's stupid all day. I'm not going to break that into multiple lines because I'm going to remove that type constraint. Or the type parameter, rather. So we actually have like in this load DSL module, we actually have a bunch of sort of different ways to represent the same thing. Like load and get results are literally identical. And the only reason that I have get results is that load felt like, load I think feels like a good name for a select statement. Because then you end up saying something like users.load, and that reads very nicely. But if you're wanting to get the results of an insert, this is only for Postgres because this requires the returning clause. But if you're looking to get the results of an insert statement, like insert new user into users.load feels really weird to me. So I call that get results, even though it's actually identical to load in every way. The other reason is because I did need get result, which is similar to first. I did need that to be a separate method because first actually adds limit 1 to the end of the query, and you can't do limit 1 for a command. Command being a thing that used to be a little bit more concrete in Diesel and maybe still will be one day, but is still what I use to refer to anything that is not a select statement. I refer to that generally as a query, and I refer to things that do stuff as commands. All right, so migrations now. Actually, why would migrations need to care about that? Oh, funny, right. So now we're at the point where it's telling me, hey, you haven't implemented query ID for your entire AST. I'm actually just thinking, is my test suite going to actually enforce that I do it for the entire AST? I must be using at least every AST node at least once. Yes, of course I am. I would never. There's absolutely no. It wouldn't be like adding a method to query fragment where it'll actually enforce that everything that currently implements query fragment implements query ID. I intend for everything that implements query fragment to implement query ID, but I can't actually do that because query fragment needs to be object safe. So I'm now actually just thinking to myself, I am relying on my test coverage. I'm relying on the fact that I am using every AST node at least once, which of course I do. But I'm like, but now really do I? Anyway, I think this is a good place to cut it off. Because I need to go eat dinner. Does anyone have any questions before I log off? Now I'm going to sit here waiting for the stream delay. The stream delay just caught up for me, by the way. This is how long the delay is. Cool. Well, thank you all for tuning in. If you enjoyed this, I think I will probably do it on a regular basis, but I am interested just to gauge how much interest there is in it. So if you don't already follow me on Twitter, in which case I'm actually curious how you found this. But I'm at SGRIF on Twitter, so please let me know that you would like to see more of it, and I will try to set up a regular schedule for this. And next time we'll have a feature to work on that's a little bit less nonsense. Anyway, so what's left here, I will tweet. I will probably finish this up after dinner. Oh right, I posted it to Reddit. That too. You can also just comment on the Reddit thing, and I will read that as well. So what's left for this is basically implementing query ID for every other AST node. We've done and adding a few tests. We've done all of the important parts, and as it turns out, implementing a really trivial method for every AST node is probably actually less mundane than it sounds, because when I say every single AST node, about 75% of our AST nodes come from 3 or 4 macros, so those aren't too bad. It's just all of the little weird one-off cases. But anyway, it's not an interesting thing. So this is the last feature I'm planning on that I foresee involving messing with the query builder at all for a while. So I think for the next stream, associations are the big feature. The ability to, given a set of, let's say users have many articles, so articles would have a column called user ID, which is a foreign key pointing to user's ID column. We have some internal stuff. Internal is the wrong word. We have some not documented or public stuff to help with that today. To allow you to join between the tables, first of all, so that you can get back a tuple of a user in an article. And then we also have some code that will allow you to load all of the articles that belong to a single user called belonging to. And that all works fine. But the missing piece there is if you have a vec of users getting back a vec of articles that are tied one-to-one with the users, that would go to zip. So doing that generically enough that it can compose well is the big blocker for 0.7, and actually the last planned feature before 1.0, other than that and time. So I think that will be what I'll work on next stream, because that will be much more interesting to watch, I think, than this one. So I will probably post to Reddit again and or tweets when I do that. And yeah, I hope you tune in. Thanks for tuning in, guys. See you next time.